Welcome to Calculus for Us. In this video we will be learning how to find the tangent and the normal of a curve. In the previous video we discussed that differentiating is basically finding the rate of change of a function at a given point. In a curve this rate of change will be different at each point, and so in a typical question for finding the tangent or the normal you will get told at which point you have to find that rate of change, and hence the tangent, the normal, at that same point. Okay, so what is the tangent and what is the normal of a curve? Well, the tangent is the equation of the line, or just the line, that just about touches that point where you would be asked to typically find the rate of change. Okay? Right, so, and the normal is just basically the perpendicular line to the tangent. That is what it is, and we will see what links those two together. It's really that simple. Okay, so let's look at a simple example to find the tangent. I mean, in this example it doesn't say to find the normal, but let's just say it says to, so part C, find the normal. And we will just do that with this question. Okay, so for part A, it just says to simply differentiate this function. Okay, so you will differentiate it. By any means, do feel free to stop the video and attempt this question by yourself first, and then turn it back on to see whether you got the right answer or not, or if this is your first time, just watch the video and maybe attempt a different question. Okay, so differentiating this, we get 2 negative. This is equal to 8, or can be written as 8x to the power of a half. So we do 2 negative 4x to the power of negative a half, because we do a half from minus 1. So we get to the power of negative a half. And then this is just 0, because it doesn't have an x, there's no power. And it doesn't follow the basic rule which of differentiation, which, if you remember from the previous video, it was when you have a number x to the power of n becomes n multiplied by x to the power of n minus 1. Okay? Same basic rule, you have to also always follow it. Okay, that's for part 1. If you want to make this look a little bit neater, because it looks a little bit ugly at the moment, we can just do 2 minus 4 over root x. Because this is a minus, so it makes it under the 4, so 4 over. And then this is a half, which can be written as a root x. Okay, for part B. Okay, for part B of this question, what you'd have to do is, well, it's just telling you find the tangent at this point. Okay, so we are told that the coordinates of where you want to find the tangent are 1 over 4, and then we don't know what the y coordinate is for this on this case. So what you'd have to do to find the y, just plug this number in to this function, and you'll get y, which in this case is 3 over 2. Very simple, just put in your calculator and you'll get the value. So, what you have to do, because remember, differentiation is finding the rate of change at a given point, so this is our rate of change. We just have to put in the point where we want to find this rate of change. Okay, so if you put 1 over 4 inside this over here, we should be able to get the gradient. So, plug that into your calculator, and the gradient that you should obtain is negative 6. That is our rate of change. So now that you've got your gradient, you've got your coordinates, just find the equation of the line, which you should already know how to do, but let's do it anyway, because that's how to find the tangent. That's what tangent is. And so we do y negative 3 over 2 is equal to negative 6, x negative 1 over 4, and just simplify that out. Let's do 6 over 4 positive 3 over 2, and then just make that neater. It's x positive 3. Okay, and this is the equation of the tangent. That's it. It's very, very simple, very easy. Okay, now let's find the answer to this question. To find the normal. Okay, so let's just get a clean page. Okay, there we go. Okay, so part C was find the normal. Okay, now from the previous question, or from the previous parts of the same question, we figured out that after differentiating and then plugging in the value of x, we figured out the fact that our gradient was equal to -6. Okay, to find the normal, what you just have to do after finding that gradient is to find its reciprocal, which basically just is. Yeah, so if it looks like this, you just have to make it, so flip it over, 1 over 6, and the negative becomes a positive. That's it. And that is now your new gradient to find the normal. Because you have to remember, the normal is the perpendicular line to the tangent. So it doesn't have the exact same gradient, but it's just the same gradient, but it's the reciprocal of that same gradient. So we can find the perpendicular line to the tangent. Okay, so going back. Here we are, this is now we're going to be our new gradient. We use exactly the same method we used to find the tangent. Okay, you've got your coordinates, you've got your gradient, just plug them in and find what the equation is. Okay, so just doing that real quickly. 6 x negative 1 over 4. Okay, 2 6x negative 1 over 24 positive 3 over 2, and then that would be y is equal to 1 over 6x positive 35 over 24. That's it. That is now the equation of the normal.